All right. So for lesson 14 today, a couple of things we want to talk about. First thing, I had alluded to this a couple lessons ago, but when you see log without a base listed, and I put an example here. If you have a log without a base listed, we're going to assume that that means log base 10. So whenever you see log with no base listed, that means log base 10. The other special log right here, is the one that says ln. Okay, ln stands for natural log. Okay, ln means nothing different than regular log. ln just means log base e. We talked about yesterday what e means. So whenever you see ln, okay, that's not a special type. It's not a special type of logarithm. It means the same as any old logarithm. The difference is it's just a base e. So whenever we want to write log base e, we're going to use ln. And when we have log base 10, we'll just write log with no base. So that's kind of a couple of important things to note for today. The other thing we're doing today is at the bottom here, we're solving exponential equations. In other words, we're solving equations where our variable is an exponent. And the way we're going to do this is, as it says right here, we're going to isolate the term with the exponent. We're going to rewrite the equation in log form, and then we're going to solve for x like we normally do. So I have actually literally 10 different examples of some types of equations that you'll see on this subject. So let's kind of hit the ground running and just start going through these equations here. So number one is 10 to the x equals 10,000. You'll notice that, again, our first step is to isolate the term with the exponent. Well, this is already isolated, so we don't have to worry about step one. Now we can take it and rewrite it in log form. So this is going to be log. Let me go back to here. This is going to be log base 10, okay, of 10,000 equals x. Okay. So because it's log base 10, we're just going to write log of 10,000 equals x. Now we should be able to do log of 10,000. Log base 10 of 10,000 means 10 to what power is 10,000? And that's going to be 10 to the fourth power. So x, in this case, is going to equal 4. If you didn't know how to do that, then we go to Desmos. Okay. And we go to functions and miscellaneous. And notice when it's log base 10, there's log with no base here. So log base 10 of 10,000 is 4. Okay. Number 2, we have 5 times 10 to the x equals 500. Again, our first step is to isolate the term that has the exponent. So in order to do that, I have to divide both sides by 5 in order to get that term by itself. So 10 to the power of x equals 500 divided by 5. 500 divided by 5 is 100. Okay. Now I'm going to rewrite this in log form. So this is going to be log base 10, but because it's base 10, I don't need to write the base. So log base 10 of 100 equals x, equals the exponent here. Okay. And we should be able to do this. Log base 10 of 100. 10 to what power is 100? That's going to be 10 squared. So x in this case is going to equal 2. Number 3, 10 to the power of x plus 3 equals 10,000. Okay? Again, step 1, isolate the term with the exponent. It's already isolated. So I will go ahead and rewrite this in log form. So log base 10 of 10,000 equals x plus 3. Now, we already know that log base 10 of 10,000, we already figured that out, that was 4. So this is really 4 equals x plus 3. And now I can go ahead and solve this by subtracting 3 from both sides. So x is going to equal 4 minus 3. Okay. Number 4, the term with the exponent is isolated already. So rewrite this in log form. So log base 10 of 10,000 equals 2x. Once again, log base 10 of 10,000 is 4. So this is really 4 equals 2x. And now I could go ahead and finish it off by dividing both sides by 2. So 4 divided by 2 is 2. So x in this case equals 2. Excuse me. Number 5, 10 to the power of x equals 315. Okay, isolate the term with the exponent that is already isolated. So we'll rewrite this in log form. So this will be log base 10 of 315 equals x. Okay. Now to figure this out, is there a way to figure out using a whole number 10 to what power is 315? In this case, it isn't. So we have to go to Desmos for this one. So we have to do log base 10 of 315. So let's change this to 315. And we're going to round that to 2.5. We'll go ahead and we'll round that to approximately 2.5. So x is approximately equal to 2.5. Number 6. Okay, I know I'm going through this kind of fast, so if you need to pause and go back, then do so. So isolate the term with the exponent. In order to do that, I have to divide both sides by 2. So 10 to the power of x equals 400. Now rewrite it in log form. So this will be log base 10 of 400 equals x. Once again, log base 10 of 400 is not going to be a whole number, so I have to go to Desmos. So that's going to be approximately, we'll call that 2.6. We'll call that approximately 2.6. Okay. Let's move on. Number 7. 10 to the power of 1.2x equals 4,000. Okay. So let's see. That is isolated already. The term with the exponent is isolated. So in log form, this will be log base 10 of 4,000 equals 1.2x. Okay. And then I have to finish this off by dividing both sides by 1.2. So x is going to be equal to log base 10 of 4,000 divided by 1.2. So to get that, I have to go to Desmos. So log base 10 of 4,000 divided by 1.2. Right. So we're going to call that 3.002. So we'll say that's approximately 3.002. Number 8. Again, we have to isolate that term, so I'm going to divide both sides by 7 to start out with. Okay, so this will be 10 to the power of 0.5x equals 70 divided by 7 equals 10. So this will be log base 10 of 10 equals 0.5x. Okay. Now log base 10 of 10, okay, we can do that, or we could just continue on here. We can divide both sides by 0.5. So we end up with log base 10 of 10 over 0.5. And we can Desmos that. So log base 10 of 10 divided by 0.5, and we get an answer of x equals 2. Okay. Number 9. Okay, so now we're doing equations involving e. Okay, is that going to change how we do it? No. So I'm still going to isolate the term with the exponent by, in this case, dividing both sides by 2. So I'm going to end up with e to the power of x equals 16 divided by 2. And I'm going to rewrite this in log form. So this is going to be log base e of 8 equals x. But remember, I talked about in the lesson notes, okay, when we have a log base e, we're going to use this special natural log. So we're actually going to write ln of 8 equals x. Okay, so log base e is the same as natural log, ln. So I can actually go in Desmos and actually get the decimal value of the natural log ln of 8. Because if you go to functions and miscellaneous, notice up here, ln is an option. So ln is log base e of, what was it, 8? Yeah. Log base e of 8 is approximately 2.08. So x is approximately equal to 2.08. And lastly, number 10. Okay, I'm going to start off by dividing both sides by 10. So e to the power of 3x. 250 divided by 10 is going to be 25. And then this is going to be log base e. So ln, log base e of 25 equals 3x. So then I have to divide both sides by 3 again. So let me write this up here. I'm going to get x equals log base e of 25 divided by 3. And if I put that in Desmos, I can go ahead and get the answer. So it'll be log base e of 25 divided by 3, and we get approximately 1.07. So that's x is equal to approximately 1.07, and that is it for the lesson for today. Your cool down will be 3 or 4 equations just like the ones that I just did.